Hi everybody. In this video I'm going to be going over the Boeing 777's overhead. Now, and if you look around my channel, you'll notice that I really don't have much about this Boeing 777. So what I did was I found a poster about showing the 777's overhead, and I decided to take a few photos, and I'm going to present you the overhead and also talk a little bit about the relevant systems from each panel. Okay, so just a basic overview. Okay, in all Boeings, the 737, 75, 76, and 777, the overhead panel is known also as the P5 panel, at least to the mechanics. So mechanics, if you're hearing me, if you're watching this video, know that the overhead panel is known as P5, okay, Papa 5. That is the overhead panel's designation in the maintenance manual and in the component location manual. And whenever you hear P5, just remember, it's the overhead panel, okay? So, I'm going to start on the left. Okay, the left we have on the 777 has on the top is known as what's called the ADIRU, Air Data Inertial Reference Unit, ADIRU, Air Data Inertial Reference Unit, and that is what is used to align the IRS in this aircraft. If you've seen my other videos, like the 767, the 757, 737, A320 videos that has the IRS alignment, that is what this is on this aircraft. Instead of knobs, it's a button, just one button. You push it, and on this one, you'll see here, I don't know if you can see it very well. You probably can't see it very well. It's right here. This little light right here is the on bat. Remember on the 767 and A320 and 737 videos, you saw that it was the little light that had on bat. The on bat light briefly flash. Well, then in this one, it's just this. It's just this one light here, and it flashes also, or when it's on. Okay. And by the way, this, with all the lights on, this configuration is actually a test button that you can push, and it can show all the lights. Although at the moment, I don't know where that button is on this aircraft, but that's what this one is. And in all the airplanes, you can do that. There's always a test button that you can use to check all of the lights to make sure all the light bulbs are working. Okay, so we're coming down here. This is just a thrust computer. You leave that alone. Because remember, these aircraft is a FADEC controlled aircraft, full authority, digital fuel authority, digital engine control, and if you just leave this alone, it knows what it's doing. Okay, coming down here is the electrical panel. I have a separate picture for that, so I'm not going to go too deeply into it right now. But in this panel is the electrical panel with APU, battery, and backup generators. I'm going to explain that a little bit more later on. Okay, moving up over here, all the window heats, the emergency lights, passenger oxygen. This is where you open it and you push it for the manual release if the automatic release doesn't work. And then the service interphone, that's to talk to the people downstairs. Okay, window heats. Make sure before you depart, make sure you turn those on at the very least 10 minutes before you actually leave, so that by the time you are airborne, the windows are hot enough that they won't break or freeze over or anything like that. That's the purpose of the window heat. The purpose of the window heat is to strengthen the windows so that they don't become brittle when you go up in altitude and the temperature drops. And but the official FAA question the answer for the official FAA question is to prevent bird strikes damage. It's kind of weird, but that's the actual answer. But it's for the same reason. The way that bird strikes come through the window is because it's weak. So when you warm it up, it kind of sort of softens it just a little bit, just enough that if there is a bird strike, it doesn't actually go through the window. So, in any case, Continuing on, here is the hydraulics panel. This is the ram air turbine. I have a small video, it's about 10 seconds long or so, 15 seconds long, of 777's rat deploying. You can find it on there, on the video, and what the mechanics are doing is they're not pushing this button. There's another button inside the wheel well, I believe. Don't quote me on that because I don't remember. But this is the one that the pilots use if the rat fails to deploy. The rat is a backup generator and for the hydraulics and for the electricity. Okay, and it only powers standby systems, and it gives you it does that by a spinning propeller off the right side of the aircraft in the back. Okay, so coming here to the down here is the hydraulics panel. Excuse me, these are hydraulic pumps. I'm not going to get into it right now. I have another picture for it later, and I'll be able to explain it to you then. Okay, coming over to the top here, this is the Apu Fire Handle. What you do is you pull it and you twist it. Now in the APU, this only has one bottle, just one. So you can turn it left or right, and it'll shoot out the bottle, and hopefully the fire gets put out. Okay, so you pull it and twist it. Pulling it cuts off everything vital to the engine, to the APU that could cause a fire, and that keeps it alive. So hydraulics, fuel, electricity, air, and then it arms the system. Those are the 5 things that it does. Okay? Now this is the cargo fire. All you gotta do is push arm, and then you flip this guard up, and you push the button to discharge it, and then that's it. This is for the cargo fire, forward and aft. Okay, and this button here, you hold it, and that's the fire chest for this APU. Okay? Here's the engine start switches. The auto start system. The auto start system is very unique in this aircraft. With if you have this button on, what it does is when you're starting the engines, and you don't have to wait till the proper N2 rotation or N3 rotation, depending on your engine, to introduce the fuel. All you got to do is turn the knob, and automatically, and you can go ahead and put the fuel cutoff levers in the on or idle or run position, whatever the word is right there on your aircraft. And once it comes up to the proper speed, it shoots out it introduces the fuel, and that's it. All you gotta do is monitor it, and if something happens, it automatically shuts down, tries to restart it a couple of times. I don't remember the specifics right now, but that is what the auto start does. If you don't have it on, you have to do all that like if you were doing one of the other airplanes. So continuing on down, and oh, by the way, you can also, in this aircraft, you can start both engines at the same time. This APU, when it's working normally, it has enough generated air pressure that it can actually start both engines at the same time. The only other airplane that I know of that's like this is the 747-400. And I'm pretty sure the Dash 8 can do it too. But of course, you can't do all 4 engines on that one. You can only do 2 at a time. So continuing on, here's the fuel jettison. It's very simple to use. All you gotta do is dial in. It's already at a preset amount in the middle, but you can decrease it and increase it if you want. And then all you gotta do is arm it, open the valves, and then pull it, and you're good. Oh, actually, no, I take that back. It's arm, pull, and fire. Okay? So, this is the fuel panel. I believe I have another picture like that later on. I can show you a little bit about it then. And then over here is the air conditioning panel and the bleed air panel. I also have pictures of that later on. And then down here is all the excuse me. I have all the lights, passenger signs, anti-icing, exterior lights, interior lights, and the wipers. In this aircraft, the captain's wiper and the first officer's windshield wiper are separated. Okay, so we are gonna go to the next picture. Okay, so see the electrical panel. So battery, APU, bus ties, secondary and primary external power, generators, and backup generators. Now, in this aircraft, there's a couple of unique things. One, it has 2 external powers. In this airplane, you don't have to have both plugs in. You don't have to have both external powers to power the aircraft, but as long as it's only for a short period, relatively short period of time. As you can see right here is the primary. On this aircraft, most Boeing aircraft, the main bus is on the left side, is the left bus. But in this airplane, the main bus is on the right side. So you can push you can have only one plug in there. Push this on, it'll power everything. Because see how this line goes? It powers the right side, and then through the transfer bus, it actually powers the left side also. But it's always a good idea if you're doing it for the mechanics out there. If you're going to be working on this airplane for an extended period of time with external power, it's always a good idea to have both in there so it doesn't overwork this transfer bus here. Okay, so primary and secondary power. This is the forward, if I remember correctly. This is the forward plug. This is the this is the aft plug. And with actually all Boeing airplanes, the external power is on the right side of the aircraft. Excuse me. And also, I believe it's this one that has like a little strap in there. I don't remember. It's been a while since I've seen it. Okay. And the unique thing about this aircraft is also it has 2 generators per engine. So, as you can see here, if this main one goes, this backup generator through the left transfer bus powers the left bus, and same thing on the other side. This one goes out, this one automatically comes in and powers it through the transfer bus. Okay, and one more thing that's really unique is the APU. Now the APU, if for whatever reason you don't have electrical power, what you can do is if you're on the ground and you have enough, and you use the air start cart, you can turn this aircraft oh my gosh, excuse me, sorry. You can turn this APU on with an air turbine starter. Just like you do with the engines, they have an air turbine starter. The APU on the 777 has an air turbine starter also. And this also helps with ETOPS. So if, just in case something happens that the battery, for whatever reason, doesn't power it, or something goes on, you can also start it like that with the air start. So it's really good. Okay, next. Oh, and one more thing before I continue. These down here, these are the IDG disconnects. So you do not touch those at all unless it's a mechanic that's testing out that system. So pilots don't touch those. It's only for the mechanic, and it's only for testing. Now, the only time the pilot ever has to use it is if it's an emergency and the electricity is not being maintained. That's the only time that the pilot can push this button and disconnect the IDG. Because the IDG, if you look at my 727 electrical video, I think it's there. I believe it's there, but if it's not, I'll tell you right now. The IDG is just like a CSD, a constant speed drive, except it has a lot more stuff in it and it's heavier. And it provides sustaining electricity, 400 hertz at 115 volts AC. And if that's not working properly, you have to disconnect it, and you only have one side to power the electricity for the aircraft. Anyways, continuing. All right, hydraulics panel. Like I said, this is the rat. You flip it open, you press it, it unlocks. That's for that. And then coming down here, this is the hydraulics. So on the 777, it's left, center 1, center 2, and right. On the 767, it's just left, center, right. Now on this it's primary and it's demand. So this is what you normally use, and this is what you use either in an emergency situation or if one of these isn't producing correctly. Now, normally you leave it all in auto for flight, so it's really easy. You don't have to worry about touching it. The only time really is for the mechanics, so they can test different systems and use it to power different things for various reasons. The But the unique thing about the 767 and the 777 is that the center system has a backup as an air system. So it uses bleed air from the APU or for the engines. Well, it's usually from the engines, because you wouldn't use it when you're in flight. But as you can see, primarily in the center system, it uses electricity to power these pumps. But if one of these fails for whatever reason, you can use bleed air from the engines to power the center hydraulic system. If you ever go on the 767, it's the same thing. The only difference is not center. The only difference is it has one knob for the air, rather than having it separately for both C1 and C2. So, now the 757 is electrical, if you ever looked at that one. So that's pretty much with all this. The only thing I will say is that the center system, it controls the landing gears going up and down, so retraction and extension. And then the right system, it powers the normal brakes. Powers the normal braking system. So mechanics, if you're towing this aircraft, what you want, if you're riding brakes, make sure you have the right hydraulic system on, because that powers your normal braking system. Okay, now obviously when you're taxiing, you don't have the engines on, because you see this is an engine-driven pump. So to make sure so you only have the APU on. So make sure you have this in the on position, not in the auto. In the on position, you don't want to wear out the auto function. So make sure, mechanics, you have this in the on position when you are riding brakes on this aircraft when it's being towed. Okay, and these are the fault lights down here. All right. So, continuing to the next one. Oh, okay, so I did have the APU panel. That's a picture of it. Well, this is a close-up view. So, see, fire, overheat test, different discharge, forward and aft discharge, EECs. This controls the engine also, and then the start buttons. Now you'll notice the difference on this airplane versus other Boeing aircrafts, where it just has start and norm. Makes it very easy. It doesn't have continuous. It doesn't have flight mode or anything like that. It's just start and norm, and then the auto start. Makes it really easy. Okay, continuing. Alright, so this is the fuel panel. So I already told you. So dial it in, arm it, and then fire. That's the fuel jettison system. It's very simple. But the fuel panel is what I wanted to focus on with this one. So on this aircraft, you have 6 pumps. Like most big aircrafts, they have 6 pumps: left, right, center. But what is unique, a little bit unique on this one, is just like the 767, it also has a forward and an aft crossfeed valve. But the one thing I wanted to say about this aircraft is that on the left side, just like on the 5.7, the 6.7, actually not this aircraft, this panel, all the Boeing airplanes, it takes the fuel from the APU on the left side. If you ever fly in an DC-9 or an MD-80, it's actually on the right side. The fuel gets fed to the APU. So once again, the Boeing aircraft's APU gets fuel from the left side. On the MD-80 DC-9 series, it gets its fuel from the right side. Now, if you ever fly a 727, which is highly unlikely, but if you're just curious about the knowledge, the 727 actually gets it from the center tank, and it's gravity fed. And that's because the APU on the 727 is actually what they call between the keel beam. So, in other words, it's just right between the wheels, the main gear on that aircraft, instead of in the back like on the other airplanes. Okay, so when you turn on the APU, you actually see this pressure light if you have external power on, and this is not on. When you turn on the APU, this pressure light actually decreases and actually extinguishes. And the reason it extinguishes is because all this does is it reads pressure inside the tank. So when when there's pressure coming from the APU, when it's getting the fuel from that side, this pressure light extinguishes. And the other unique thing is that This is with the APU. Well, actually, no, it's not unique, but the APU gets its fuel with a DC pump. DC is DC powered. There's a direct current that comes from the battery, so that's why when you start the APU, you always need a battery. So when you turn on the battery, you switch the APU to on to start. It uses its own DC pump to get fuel, and it's right around here. And then when it turns on, when it gives the AC power, it actually turns off the DC pump and switches over to this pump, even if this is not on. It switches to the AC pump. So, and the 767 does the same thing. Oh, next picture, and I believe this is the last one that I have. So this is a view of the pneumatics panels on this aircraft. So reciprocating fans, these are the pack controls left and right. Gasper fan is just a little eyeball looking thing over your seat. The trim air lets it go into these different sections. Left pack, right pack. The APU, left engine, right engine. Bleed air panels and the pressurization panel. The pressurization panel on the 777 is extremely simple. Just leave it in auto, and it does the rest. The manual control, I didn't get the picture actually cut off here, but the manual control for the forward and aft outflow valves is actually right here with a little switch. And yeah, that is the unique thing about this aircraft. The 777 has two outflow valves. It has a forward and an aft. So if you ever see a 777 taxiing or at the gate, try to look for it's on the right side of the airplane, right side of the nose, and you'll see the forward outflow valve. Okay, and I believe that's it. Nope, it's not. This is the last picture. I know for sure this will have the last picture. On some 777s, it has these entertainment and cabin or seat power buttons on it. That's what these are. If you ever look on a 737 NG, and you look right where the electrical panel is, or the meters are, where the battery is, you'll see these same things. The in-flight entertainment, IFE, passenger seats, and cabin utilities, the galleys. The galleys and the toilets. Sometimes it has, so you'll see a switch, two switches for these, right there on the 737 NG. And some, like this thing says, some aircraft, 777, some 777s have it separate, some don't. So, anyways, that's it. I know this video wasn't the best quality, but I hope it was informational enough for you guys. And I'll see you later. Have a good one. Bye.